Let's bring it in. There's a few more things we want to get covered tonight before we break for the evening. So I'm going to go ahead and write a solution to this, but with Pandas, there's a variety of ways in which you could arrive at the destination you're trying to arrive at. We'll talk about some of those variations here shortly. What I've written is I want to select the wines with volatile acidity less than some number, and then obtain the mean density of those alone. So we're going to break this down into two pieces. First, we want to select those wines with a volatile acidity less than 0.58. So I gave a bit of a hint, but I didn't explicitly show you how to do this before I gave you the problem. You can do Boolean indexes in the same way you can with NumPy on Pandas objects, in particular with series objects. So if I select a column like volatile acidity, I can't say that word tonight. It like hits the wrong syllables for me. We can select out that one column using these open square brackets. That gives us back a series object. If I then do something like less than 0.58, that operation will give me back a series that's made up of trues and falses. So it's of D-type bool. I can then use that series to select values, or in this case, select rows out of my data frame. Because this Boolean this Boolean series has exactly the same index as the data frame that I created it from. So I could use df, that very data frame. I could feed this into those square brackets, and this will give me back a data frame that has only those rows for which that statement was true. So we went through how you could select columns, we went through how you could select specific rows based on labels. But what's oftentimes the case is you'll take a data frame and sub-select pieces of it based on the values of certain columns, or maybe the values of many columns put together. It's possible to build pretty complex Boolean series from this. I'll do an example shortly. So this gets us back a data frame that has only those rows for which this condition is true. We then want to obtain the mean density for those rows. One thing we could do is we could call .mean immediately, and this would calculate the mean of every column. And then we could select out the mean of density, since the result of that operation is it gives us back a series object, which we could then select density based on the mean of density based on the label. It turns out that when you get pretty big data sets, you might want to consider what's the more efficient route, though. It's usually fine to start with something that just gets you to your destination, but it turns out that it's more efficient, instead of doing this, it's more efficient to do this, even if they give you the same result. The reason being is that if I call this, the result of selecting out density from that resulting data frame that came out of our filter is that I'm selecting a single column, and then if I call mean on it, I only have to calculate the mean of a single series. If I flip density and mean around, what I'm doing is I'm calculating the mean of every column and then just selecting the one I want. So for this data set, you're not going to notice a speed difference, but for bigger ones, the order of those operations could mean a substantial difference, especially if there's just one piece of something much larger that you're doing, or you're operating on many data frames. Maybe this is one wine data set, but you've got 1,000 of them, and you're going through them in a loop. That could add up pretty fast. So looking for those little places where you can find a more efficient path to something you're trying to calculate is something to think about. It's not the first thing to think about, but it is something to think about later. Any questions on this example? I mentioned that I would give you an example of a more complicated Boolean index. So running this operation gives me a series with bools in it. If I run an operation like, let's choose a different column, let's do residual sugar. And let's say I want only those rows for which the residual sugar is greater than or equal to 1.6. That will give me a different Boolean index. What if I wanted only the rows of my data frame for which the residual sugar was greater than or equal to 1.6 and the volatile acidity was less than 0.58? What I could do is I could take both of these Boolean series and do the AND operation between them. And that would give me a Boolean series that if I then use that to index my data frame, would give me only those rows for which both those things were true. And so we're going to do that. The way you can do that is you'll have to use parentheses here, residual sugar, and then you'll need to use an ampersand. You can't use the AND, Python AND word, because you're not taking an ANDing of two series, you're taking a bitwise ANDing, meaning element-wise ANDing is what you're really trying to go for, and that's what the ampersand means. It says on a per element basis, do an ANDing. And so if I do run this cell, that would give me the ANDing of those series. And I could then feed that directly to the indexing of my data frame with those square brackets, and that will give me my final result. If you wanted to write something where you wanted rows where this was true or this was true, then you wouldn't use an ampersand, you would use a pipe. A pipe means do a bitwise OR. Okay? You could build up some pretty complex statements with this scheme. So, and this is probably one of the most common things I'd say I do with pandas is when I have a big data frame, I probably want only a subset of the values that I want to do something with that match some kind of conditions. So this is something to definitely remember that you can do with pandas. Now, pandas also has a query method, or data frame has a query method, which allows you to write some things like this a little bit more easily. Like you could write density less than, let's have a look at what we actually have to work with. Density is less than perhaps 0.8 maybe. Nope, that doesn't get us anything. 0.9, 0.998, that gets us something. So query kind of gives you similar functionality. You don't have to write something quite as verbose. There are limitations to query though. It doesn't do well with columns that have spaces in them. So all of our columns here have spaces. This is going to give us an error. I think you might be able to pull this off. I could be wrong. Yeah, it does not like that. So I generally don't use query because sometimes you get weird column names that it's not going to like. But point is, it's there. It's a convenience. And generally speaking, if you can make your columns have no spaces at all, that's kind of a wise thing to do up front. We didn't do it here, but it is possible to change all your column names. Let's go ahead and do it just to show practice here. You can edit your data frames just as much as you can work with them and do descriptive stuff from them. for example, if I wanted to create, or if I wanted to change all my column names, let's first grab our column names. If we call df.columns, that gets us the names. I'm going to set it equal to this names, or set this name names to point to it. And then what I'd like to do is I'm going to do a list comprehension on this. I'm going to say name.replace space with an underscore for name in names. So if I write a list comprehension like this will give me back a list where all of the spaces in each of those elements were replaced with underscores. So we kind of eliminated the problem. But now we need to take our data frame and set those columns to have those names. So something I could do is actually say df.columns. I could set that directly equal to those names and it will replace them. So we see in our new view here, our data frame now has new column names. If you recall earlier in this course, I talked about mutable versus immutable data structures. For example, a tuple is immutable, but a list is very mutable. You can add elements to it. A data frame is an example of a mutable data structure. Even though most of its methods return new data frames, they don't edit the structure, you can edit an existing data frame in place. You could even change the values of certain things. For example, if I said .loc, where I'm accessing the rows, if I say .loc 6, and I select chlorides, 6 comma chlorides will select that particular element that's at row index label 6, column chlorides, and it's certainly currently set to 0.69, but maybe I don't think that's right, and I'm going to set it to something else. And if we look at our data frame now, we've set that number to 7.8. So you can directly operate on the elements of your data frame if you need to. You can edit it. Obviously, be careful with this. If you're reading in a data set and you expect it to reflect the data set as it was in the file, then you might have something completely different that you're now working with later. So you can also do operations between columns. So if I take, for example, let me grab my column names again. Say I have free sulfur dioxide and total sulfur dioxide, and I would like a new column that gives me the fraction of free sulfur dioxide. So maybe take free sulfur dioxide and divide it by the total. What I could do is I could say free sulfur dioxide divided by df total sulfur dioxide. And because both of those columns share the same index, if you do division like this or any kind of arithmetic operation between columns, then the operation will be between elements of the same index. So it'll be like to like. So if I do that, I get back a new series. That's the result of doing division element-wise. And if I wanted to, I could make a new column. I'm going to call it frac free sulfur, if I could spell dioxide. And I could just use the assignment operator equals. If I run this, we'll see that my data frame actually has a brand new column right at the end of it. Yes?
Can you change the column name to just when you return the results, you just change the column name to something more user-friendly, like your ads, like
Oh,
Just changing the column name.
so change, if you, well, it's possible to change names. So we could, is that what you're going for?
Yeah, but just when you return the results, you don't want to change the column name fully.
So, okay, yeah. So I would say the way to alias a column name, so say you didn't want to type in total sulfur dioxide and deal with that all the time, but you wanted to work with that column. Is that what you're asking?
That's fine.
Yeah, I don't think there's a way to create a bunch of aliases, and I would say it might get confusing real fast if you create a bunch of aliases but also have the real names for them. But you can always rename columns and then name them back later. So oftentimes a data frame may not be in a form that I need it in the current form it is in, so I'll first transform it into something that is more useful, like switch out the index for something more useful, and then use it in the way I need to. There is a rename method that allows you to feed in, for example, as keys existing column names like chlorides. I'm going to call these fuzzy lumps. And the resulting data frame is going to have, you have to specify the axis on which that rename is going to apply. If I say axis 1, that says do it on the columns. So you see that now chlorides is named fuzzy lumps, for example. So that would be one way of getting the effect you want. And this is a new data frame. So the original is still intact. If you wanted to rename in place, then you'd have to do in place equals true. And that would edit the data frame. Does that help?
No, that's exactly what I was.
Okay, good. Okay, so the last thing I wanted to talk about before we leave for tonight, well, actually, there are two things. We might run out of time. Are group bys. So we will get into that. So it's often the case that we don't necessarily want to get statistics for, say, an entire column or maybe even a subset of values. What we would like is to say, you know what? I would like to take my data frame and I have something like this quality column here that has values like 5, 6, 7, 8, 9. If we look at quality and we ask what are the unique values of it, it has a fixed set of values. So one thing we might want to do is to get descriptive statistics of all the other columns, but as a function of the values of quality that are present. So maybe for only those rows for which quality is 5, I want to get the mean sulfates that are present. And then I also want the same result for all of those rows for which quality is 6 and for which quality is 7, but I want them separately. This is what a group by affords us. We're saying group by quality, the value of quality, and then apply some kind of operation and give me those results. Let's see an example of this. I can say df.groupby, and I can feed in quality. And if I just run this as it is, I'm going to get back a pandas group by object. All of this object represents is the group by itself. It's that operation of grouping by those values. And it exposes a lot of methods that we can then call directly. If I say .mean on that, I'm going to get back a data frame that has as its index the various quality values that were present, 3, 4, 5, 6, 7, all the way to 8, and I'm going to get every other column that was present in my data frame, and what the values represent are the mean values for those columns as a function of quality. And that's all group by is. With Pandas, you could group by multiple columns as well, so if you had two kind of sort of categoricals like quality, you could say group by both quality and color, right? So for example, we've got a white wines list is the other data set. We could combine these into a single data frame and maybe add a new column called color. And I could then say group by color and quality. And then you'd get reds, 5, 6, 7, 8, 9, whites, 5, 6, 7, 8, 9. And you'd be able to see all this data in one place and do all this stuff directly. Okay? There's lots of things we can do with group bys. We could also do, for example, we're going to get directly into plotting. Let me see if this works as I just want to try it out. Oh, that's going to be a disaster. Hold, please. It's going to be big. Yeah, I need to matplotlib inline. We're going to quickly cover some visualization. That was basically the basics of group by. There's more detail there. You guys will have a homework. And next time, we'll also be doing some more pandas. So I think I'll eke out some time for doing some more group by operations there. But for now, if you go ahead and call matplotlib inline, I'm going to try running this, but we're going to select out a specific column, like, sorry folks, let's do a column like fixed acidity. Fixed underscore acidity, one of those words I can't say well. This is an example of visualization with Python, with pandas. What we did here, I'll describe it, is we took our data frame, we said group by quality, so group by these values, and then select out the column fixed acidity, or that particular variable fixed acidity. And the result of this is still a group by object, but it's a group by with a specific column selected. We can call .plot on that object, and we said make a histogram out of it. This is giving us the distributions of fixed acidity as a function of quality. So each one of these histograms corresponds to a different value of quality. So we can see kind of how the quality varies, or not how the quality varies, how the fixed acidity varies as a function of quality, but visualized. If I do legend equals true, I think that'll actually give me something that's a little bit more useful. There you go. Now you see the colors associated with each of those values. And if we go a little bit further and say, instead of a hist, let's do a kernel density estimate. We'll talk a little bit more about these various visualization types in a couple weeks when we actually have some lessons on this. But this is essentially a histogram where we've done some smoothing on the data. So you can see how density on the how density, which is actually on the x-axis, these density values, varies as a function of quality. What this shows is how many, relatively speaking, wines had, say, a density of 10 or 5 for each of those qualities. So we saw that what we see here is that for quality 5, most of them have a much narrower range of densities. So the whole set of quality 5s seem to fall into this range of densities, whereas some of the other qualities, like for example 8, which is this sort of dark violet or maroon line, has a wider range of densities. It might be that there's just more rows of quality 8, and so there's more representation there, but that's something we could explore with our data frame, is to ask those questions. Well, how many are there of each quality? In fact, let's just get that. If I say group by quality, and I say .count, that would get me, looks kind of stupid, this data frame, because it just has the same value in every column. But it says there are only 10 rows of quality 3, 53 of 4, and then there was actually like 600 or so of 5 and 6. So some of that histogram we just drew might be that we actually just have more samples of some of this than the others. So make your conclusions with caution. All right. Data frames themselves also have a plot method. So if we look at our data frame directly, we can call, let's actually use this example up above, fixed acidity. If we select out that column, fixed acidity, with an underscore, and we say dot plot kind equals KDE, we can basically get the same plot we got before, but just with fixed acidity, but for all qualities. We didn't separate them out. So normally I'd introduce this kind of in the other direction. The point is there's a plot method attached to series objects, attached to data frame objects, and attached to group by objects. And you can use this to do very quick and dirty visualization. And in fact, these visualizations are all created with Matplotlib. So underneath the hood, Pandas is using Matplotlib, which we saw a little bit of on Saturday. We'll have an actual deep dive into that topic in 2 weeks from now. But he's using Matplotlib, so all the skills you learn over time of how to manipulate Matplotlib figures apply to these, because what's returned from here is an axis object. And I could actually manipulate this axis object by saying, let's, for example, add an x-axis. Let me say set x label to density values. And the result is I'd get a figure that has the right label on it. So everything you learn about Matplotlib will apply to Pandas's convenience plotter. So it's not time wasted, basically. Matplotlib is still the dominant plotting library in all of the Python ecosystem. Let me talk about your homework. If you go back to your notebook overview of the directory, you'll see 2 notebooks are already there. One of them is Lesson 5 Pandas. This is essentially tonight's lesson, although I tend to improvise a lot when people ask questions and whatnot, so not everything I said is going to be directly in that lesson. This is mostly what I was planning to say. But feel free to browse through it, play around with that notebook. It'll still be a useful guide for you. If you crack open this notebook, Lesson 5 assignment, this is your assignment between now and Thursday. Go through this, do the problems. Unfortunately, because we're not running in the Learn module here, you're not going to get instant feedback as to whether it was correct or not, but you should be able to figure out if it's correct by doing some testing of what you've written, kind of like how I do when I'm up here at the beginning of class. Try things out, play with it. Ask the Slack channel if you have questions. I'll still be watching it. I'll actually be working a lot tomorrow, so if you happen to crack this open in the middle of the day on 4th of July and you're not doing anything, because you have no life like me, I was meant to deprecate me, not you, so don't take that personally, please. Yeah.
Plots were like fireworks, right?
What now?
Plots were like fireworks.
They're like fireworks, yeah, exactly. Just make yourself lots of pretty plots. That might be one way to pass the time. Anyway, do this before Thursday. On Thursday, we'll be picking up with SQL, which kind of related to Pandas, a lot of the same ideas. It's tabular data, there's group bys. We didn't cover joins and merges today, but we'll probably be able to cover some of that with Pandas on Thursday. So see you all then.